we will be once again looking at the limit definition of an integral, this time on a problem that is slightly more complicated than previous examples. Notice, however, that the rules don't change. We're still taking the limit as n goes to infinity of the summation of I equals 1 to n of f of xi times delta x. Step 1, delta x is going to be b minus a, where b is 3 and a is 0, so 3 minus 0 divided by n, so it's 3 over n. Step 2, xi is going to be equal to a plus I delta x. A is 0, so it's going to be 0 plus I times 3 over n, which is nothing more than 3i divided by n. Next step, we're going to go ahead and find out what f of xi is, which again, remember, every time you evaluate f of xi, there shouldn't be any x's actually left. It should be all i's and n's. So when I plug this value right here in for x into this function up here, I end up with 3 parenthesis 3i over n squared plus 1. This provides me with 3 squared, which is 9. 9 times 3 is 27. I squared is I squared, divided by n squared, which is n squared, plus 1. This is my f of xi. So now I have delta x, and I have f of xi. So I'm going to go ahead and evaluate the summation as I equals 1 to n of f of xi times delta x, which is 27i squared divided by n squared plus 1 times 3 over n. Remembering again that we can distribute this piece in and simplify as much as possible, and then tear apart these summations. One more time, expectationally, I do not need to see all of these simplifications occur and the tear aparts occur. What needs to happen is it needs to be very clear that you understand what's going to happen as we go from here to here and how these things break down and simplify. So for instance, this one, the summation of a constant inside the summation such that we're going from 1 to n is nothing more than that constant multiplied by, if I'm going from 1 to n, just n. This one right here is going to be that constant 81 over n cubed, 81 over n cubed times, I'm going to put that plus sign, that's that plus sign, times the summation of I squared. We're calling it the summation of I squared is n plus 1, 2n plus 1, all divided by 6. So again, 81 over n cubed, that's that 81 over n cubed, we take it out of the summation and then evaluate the summation of I squared. Here, it's just the evaluation of the summation right here, where all of this stuff here is just a constant, so n times that constant. Lastly, we're going to go ahead and simplify this as much as possible, and one more time, we're going to do the limit as n goes to infinity of that entire summation. So very carefully, I'm going to cancel details out that I can. The n and the n can cancel out, leaving me with a plus 3. Over here, this n cubed can cancel out and become n squared with this n. The 6 can cancel out, become a 2 with this 81 and become 27. So it looks like I'm left with a 27 over n divided by 2. So I'm going to go ahead and write 27 divided by 2n squared multiplied by everything that's left in here, n plus 1 times 2n plus 1, which we've done before, is 2n squared plus 3n plus 1. So we'll distribute this piece into that set of parentheses, simplify, and then finally evaluate the limit. The limit as n goes to infinity of, when I simplify as much of this information as possible, the 2n squared cancels out with the 2n squared, leaving me with 27. The 27 will distribute to the 3, making it 81. The n squared with the n will cancel out and leave me with 1n in the denominator, and the 2 will remain. When I distribute to the last piece, I get plus 27 over 2n squared, and then finally plus a 3 tacked on to the end. You'll notice now that I have, as n goes to infinity, a constant, something divided by n, something divided by n squared, and another constant. The pieces that divide by n squared end up going to 0, and the pieces that are constants simply go to those constants. So this limit is finally equal to 27 plus 3, which is 30. So the argument is the area under the curve of 3x squared plus 1 from 0 to 3 is the value of 30.